Okay, folks, section 8.7, square roots. Now listen, this is important. This is stuff we're going to use tomorrow with the Pythagorean theorem. What? You'll find that out tomorrow. Okay? Now, square roots. The square root of a number, okay? The square root of a number n is the number that when multiplied by itself will equal n. So let me ask you this. The square root of 25 is the number that when multiplied by itself gives you 25. What number multiplied by itself gives you 25, Elizabeth? 5. Okay, so 5 is the square root of 25. Good. Okay. Now, they have another example here. They say, for example, the square root of 16 is 4 because 4 times 4 gives us 16. A number multiplied by itself equals 16. Now, it says a table of squares and square roots appear on page 671 in the back of the book. You guys are going to use the calculator, okay? And I'll show you in a moment how you use the calculator to find the square root, all right? Now, let's look at this a little bit right here. It says the square root of n is denoted, that means is shown, is written, is named by that little check sign that kind of looks like a division, but it has a check on it, over n. This little check sign is called a radical, or a radical sign. Okay? It's radical. Now, look over here. It says calculator tip. You can use a calculator to approximate the square root of a number. For instance, the square root of 8. Do this for me. Take your calculators out. Turn them on. Clear it. And then I'd like you to press these two buttons. Press the square root symbol, and the square root symbol you're going to see is just above the 7. Do you see that? Okay? And instead of doing 8, let's do the square root of 12. So you hit the square root symbol and then type 12 under it. And what do you get? Give me everything that you see on the screen. What did you get? Zachary?
3.4641016.
Wait, I'm sorry. 3.4641?
Yes, 01615.
Okay. If I take the square root of a whole number, but I don't get a whole number, this goes on forever and ever, just like pi does. It's called irrational. Okay? If I take the square root of a whole number, do you agree 12 is a whole number? Okay? If I take the square root of a whole number, but my answer's not a whole number, it goes on forever and ever. It's irrational. Okay? Now that we know how to do that, let's go ahead and do the first ones from this example here. Okay? This first one says the square root of 49. Can you tell me, raise your hand, what is the square root of 49? Emma?
7.
It's 7. Now let me ask you something, Emma. Did you need to use your calculator for that one? No, you just knew 7 times 7 gives you 49, right? Now, Emma, let me ask you this. Is 49 a whole number? It is. And we took the square root of it, right? Did we get a whole number as our answer? Good. So it's rational. That's a good thing. That means it doesn't go on forever and ever. Okay? Who's going to do B for me? Raise your hand. This one says the square root of 6.25. What did you get for that, Rowan? 2.5. Perfect. That's nice. No, it wouldn't. But this isn't the square root of a whole number, is it? Right? It's a decimal. So it's not a whole number. Now let's look at this last one here, the square root of 8. Now this is a whole number. Allie, will you read to me what you got for the square root of 8?
2.8284272125.
All right. And I'm going to put dot, dot, dot there. Why did I put dot, dot, dot there? Why did I do that, Moreau? Because it's what? It goes on forever, and we call that irrational, right? I-R-R-A-T-I-O-N-A-L. Irrational. It goes on forever. It means it never stops. It means we can't write it as a fraction. Okay? Everybody feel good about that? Know how to use their calculator? Good. All right, let's look at the next one.